and welcome to this video that covers this rate of change question. So here we have a sheet of metal with a description that says the horizontal base is a rectangle measuring by 8x by y centimeters and two vertical sides of trapezia of height x with parallel edges of length 8x and 10x centimeters, and the remaining two sides are rectangles inclined at 45 degrees to the horizontal. Given that the capacity of the tray is 900 centimeters cubed, find an expression in terms of y. So for this one here, we want to find the volume of this shape because that's what we're given. So this can be treated like a prism, but with the prism this time with a trapezium as the essentially the area, the cross-sectional area. So this is an example of the trapezia that we're looking at. Now the general formula for a trapezia is a plus b over 2 times h, where a and b are the sides and h is the height of the trapezia. 10x, a is going to be 8x, and the height is just going to be x. So therefore from here we can just find what the area is of this shape, which is going to be 10x plus 8x divided by 2 times by x. So 8x plus 10x plus 8x is 18x over 2 times by x, so that's going to be 9x squared. And then we're going to times that by the volume, sorry, not times by the volume, so we're going to times it by the length. So the length of this shape is y, which is this part here, and that will find the volume of our shape. So the volume is equal to 9x squared times by y, so it's 9x squared y. And we know that the volume is 900, so we can say that 900 is equal to 9x squared y. And then we want to find an expression for y in terms of x, so we're going to divide both sides by 9x squared, so 900 over 9x squared is equal to y. 900 divided by 9 is 100, so we end up with 100 over x squared is equal to y. And that gives you your first answer for part A. Then for part B, show that the area of metal used to make the tray a centimetre squared is given by 18x squared plus 200, 4 plus root 2 over x. So for this one we need to consider what we actually have in terms of the area of our shape. So we know that the base of the shape is a rectangle, so we can put essentially part 1, the rectangle. So the piece of metal at the bottom is going to be 8xy. We then also know that we've got the trapezia, which is on the side, so this is going to be shape 2. So shape 2 we've already calculated the area for, that's the a plus b divided by 2 times h, which we've used for our volume, so that's going to be 9x squared, but we've got 2 of those, so we're going to times that by 2 because you've got 1 on either side. The last part that we have is going to be the rectangles which are angled at 45 degrees. Now the issue here is that we need to find what the side is of this length here, and to do that we're going to make a triangle. So if we just draw the shape out a little bit out here, so we want to find this shape here, so we're going to call this C. So C is going to make up the rectangle that's at 45 degrees, but it also forms part of the side of the trapezia. We know already that the top part is 10x, we know the bottom part is 8x, and because this is going to be equal in either side, we can actually split this into triangle, and we know that the difference between the top and the bottom is 2x, so therefore it's going to be the same either side. We know that the bottom, this part of the triangle, must be x. If you add this extra part here, we know that from here to here is 8x because it's the same as the bottom, so the extra part, so hang on, let me make this a bit more clear. So this here is 8x. We know that the total length here has got to be 10x. We therefore know that the middle part must be 8x because that matches the bottom, so that makes a rectangle, and then the two bits are equal on either side, that gives you the x on either side. And then we know the height already, that's given in the question, that's x. So here we can make a triangle, a right angle triangle, x, x, and we want to find what c is. Well, for that we can use Pythagoras' theorem. So it's going to be c squared equals x squared plus x squared. So c is equal to the square root of 2x squared. So c is going to be equal to root 2x. And so therefore when we do our rectangles, so shape 3 here is a rectangle. One of the sides is root 2x and one of the sides is going to be y. And we've got two of those, so it's going to be root 2xy times 2. So we know that this is going to be the surface area, so therefore we can say that the area is going to equal 8xy plus 18x squared plus 2 root 2xy. And we can put this together to make it a little bit more straightforward. So this is just going to be 18x squared plus 8. Actually, we know that both of these have got xy and xy, so it's going to be xy 8 plus 2 root 2. Now, we've got part of our equation, we've got the 18x squared, but we've got our second term. Now, in our term, we've got a y, and in the answer term, it doesn't have a y. So that's just, we're going to use our answer from part A. So we know that y is equal to 100 over x squared. So we're going to substitute into our question. So 18x squared plus x times 100 over x squared, 8 plus 2 root 2. From here we can cancel out one of the x's, so that's going to be 18x squared. So we know that that's going to be x at the bottom. And we can also here take out a factor of 2, because we've got a factor of 2 from the 8 and a factor of 2 from the 2 root 2. So this, therefore we could take the 2 outside and multiply that by 100, which is the number we've got outside here. So it's going to be 200 times 4 plus root 2. And that will give us our final answer, 18x squared plus 200 plus root 2. 200 times 4 plus root 2 over x. And there we go. So the third part is find to 3 significant figures the value for x which x is stationary. So from here we know that this is a. If we're going to find the stationary part, we're going to differentiate, so it's going to be dA over dx. So again, I always rewrite this if we've got a x that's over the top, so it's going to be plus 200 4 plus root 2 to the power of x minus 1. So if we differentiate this, it becomes 18 times 2, which is equal to 36. So it's going to be 36x plus, no, it's going to be minus, because we're going to times it by minus 1, so minus 200 bracket 4 plus root 2 x to the power of minus 2. And we know that because it's a minimum, that dA dx is equal to 0. Is it a minimum? Let me just find out. Yes, find the value for x which A is stationary, so we don't know yet. But it's stationary, so we're going to say dA dx equal to 0. So 0 is equal to 36x minus 200 bracket 4 plus root 2 over x squared. Note here that I put back the x underneath the fraction, as back to the denominator with the negative. This helps us because then we can then easily solve the next part, because we need to times everything by x squared. So that's still 0 on the left hand side. 36x cubed minus 200 bracket 4 plus root 2. Move that over to the other side and we get 200 4 plus root 2 equals 36x cubed, and then we're going to divide by 36, and then we're going to cube root our answer. Oops. And that gives us x. So then from here we plug that into our answer, so it's the cube root of bracket 200 4 plus root 2 divided by 36, and plugging that in we get x is equal to 3.109956342, and the reason why I'm writing long answers is because I need to check how many significant figures we've got. So he wants the 3 significant figures, so then we write down to 3 significant figures. So x is equal to 3.1, and the third significant figure, the 9, rounds it up, so it's going to be 3.11. I think it's centimetres, I haven't actually checked the units, and it is centimetres, so that's the value for x, which a is stationary. And then the next part is find the minimum value of a and show that it is a minimum. So for part D, we can do the first part is just to plug in x. So for part D, we just plug x back into A to find our minimum area. So 18, 3.11 squared plus 200, bracket 4 plus root 2 over 3.11. And then plug that into calculator. Here you might want to use the answer function. So that's going to use the whole answer from before. That will give a more precise answer, but you should be fine using your 3.11 value that you've just found. So here your area is equal to 522.2787, which to 3 significant figures is just 522 centimetres squared. And then the second part of the question asks to prove that it's a minimum point. So for this one here, again, we're going to start with our dA dx term, which was 36x minus 204 plus root 2 to x to the power of minus 2, and we're going to differentiate again. So dA dx is equal to 36, and this time we're going to times by minus 2, so it's going to be plus 400, 4 plus root 2, x to the power of minus 3. And then here we're going to plug in our x value. X is equal to, again, this might be a bit hard to use the answer key, so we'll just use 3.11. So dA over dx is equal, we're going to sub in x equals 3.11 into this equation, so you get 36 plus 400 bracket 4 plus root 2, and then 3.11 to the power of minus 3, and that gives an answer of 107.997. So that's I forgot. So here when we differentiate, it's obviously d2a dx squared. So we second differential, apologies. But we know here that d2a dx squared is greater than 0. Therefore, it must be a minimum point. And that is the question solved. If you have any questions, please let me know.